Bristol Community College, Mathematics with Dan Avedikian, Math 119, Fundamental Statistics, Section 10.4, Problem 4. This is Section 10.4, Problem number 4. It says 90% of students tell their teachers that they do their homework every day. Tom, the terrific teacher, thinks that some of them are lying. Some investigation reveals that out of 100 people studied, only 84 actually did their homework every day. If Tom conducts a hypothesis test at a 5% level of significance, will he conclude the percentage of people that do their homework every day is less than 90%? So this is a hypothesis test. Let's start the process. The first step of 6 steps is to state the null hypothesis. So the symbol for null hypothesis is a capital H with a subscript of 0. We put a colon. And most hypothesis tests use a symbol next that's mu, which is the symbol for the mean of a population. But since we're testing a proportion or percentage, we use p. And then use a symbol that contains equality. It'll either be equal to, greater than or equal to, or less than or equal to for the null hypothesis. We'll use equal to. And we're going with 90%, which as a decimal, you have to enter it as a decimal, is 0.9. And you can put 0.90, but 0.9 is fine. And the next step is state the alternate hypothesis. Capital H with a subscript of 1, you put the colon. You can have the same p, the same 0.9, but a different symbol. In the alternate hypothesis, the symbol will always be either less than, greater than, or not equal to. Now in this case, what are we testing? That the real percentage is less than 90% or 0.9. So we use a less than symbol. So that's the second step, stating what the alternate hypothesis is. And now the third step is, what type of test is this? Is this a left-tail test, right-tail test, or two-tail test? So if you have an inequality symbol in your alternate hypothesis, it will tell you what type of test you have. The inequality symbol points in the direction of the type of test. My less than symbol points to the left, so this is a left-tail test. And what that means is if we see the graph, the critical region will be in the left tail or left end of the graph. Now, how big is that critical region? The question says use a 5% level of significance. So it's the leftmost 0.05. So if we get into that leftmost 0.05 critical region, we're going to reject the null. And if we don't quite go out into that critical region, we will fail to reject the null. So we'll see what happens. So the next step, the fourth step, is to calculate the value of z. And the formula to do that is z equals x, the observed number of successes, minus n times p, where n is the number in your sample, the sample size, and p is your proportion that you're testing, or percentage. And in the denominator, you will have the square root of n times p times 1 minus p. So we'll go ahead and fill that in. We'll have z equals x. Your observed number of successes for this problem is 84. There were 84 students that they found that were actually really doing their homework every night. It'll be minus n, the size of your sample. So for this question, it says there were 100 people that were studied, so that's the size of the sample. That's the n, 100. And p, the proportion that you're testing as a decimal, is 0.9. So that's the numerator. And now in the denominator, we'll have a square root of n, which is 100, times p, which is 0.9, times 1 minus p, so 1 minus 0.9. So now we'll start the process of the computation. In the numerator, we will have 84 minus 100 times 0.9 is 90. And in the square root, 100 will stay for a minute, the 0.9 will stay for a minute, but I will put in 1 minus 0.9 is 0.1. And go a little further. The numerator, 84 minus 90 is negative 6. Don't lose a negative. And in the denominator, When you multiply 100 times 0.9 times 0.1, it comes out to 9. Don't forget it's still under the square root though, so square root of 9 is going to be 3. So you'll have z equals negative 6 over 3, which reduces to minus 2. So that's step 4. Calculate z, and we did. Z is minus 2. So now the next step, step 5, look up your value for z in the standard normal probability chart, which is at the end of the homework. So to look up a value in the chart, the first thing you want to do is write it so that it has 2 places after the decimal. So that negative 2 will have to be written as negative 2.00. Then the next thing you're going to do is split the number to look up into 2 parts by pulling off the rightmost digit. So it will split into negative 2.0 and just 0. And then the next step is put a 0.0 in front of the rightmost digit that you pulled off. And then finally, the last part of the process, what you're going to do is the digits from the left will tell you what row of the chart to look in, so the negative 2.0 row. And the digit from the right with the 0.0 in front of it will tell you what column of the chart to look in, and you see where those intersect. And again, you have to remember it's the negative page of the chart, because there's a negative page and a positive page. Make sure you're on the negative page. And when you intersect the negative 2.0 row and the 0.00 column, they will intersect at 0.0228. That's step 5. Look up z. We looked up z and we got 0.0228. Now, step 6, state your conclusion. Should we reject the null or fail to reject the null? Well, did we go into the critical region? Are we in the leftmost 0.05? Well, actually we are. 0.02 something. You're about halfway into that critical region. So we are in the critical region. So when you get into the critical region, your conclusion is to reject the null, which means you feel that it is more likely that the alternate hypothesis is the true statement, which in this case is that the percentage of people that really do their homework every day is less than 90%. So the final step, step 6, state your conclusion. Your conclusion is reject the null hypothesis.